Shall we do a podcast instead?
Yeah. We might have already started.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 353, Fantastic Peripherals, Fake or Not Fake Picos, and Everything on the Steam Deck. This week in Hackaday news, an emergency return from the ISS due to medical concerns.
First of its kind, which is kind of remarkable if you think of the 26 years or whatever it's been that the ISS has been continuously crewed, that this has never happened before. I mean, probably speaks to the average health of the astronauts and the care taken to make sure everybody's doing their job. This morning, as of us recording this on Thursday, crew 11 astronauts came back, only one of which is ill, but NASA, to protect the information of their people, isn't saying who it is and what it is, and there's a good chance we might actually never know because, these are still private citizens and we don't technically have the right to know about
none of your business.
Yeah, their medical history. We might pay their salaries, right? But they're still just normal people. So, but everybody's home, and NASA said everybody's stable, and it sounds like it was just one of those abundance of caution things. But when you're in space, you kind of need to take things a little bit more careful than when you're just at home and have a headache or something like that.
We're going to be talking about this in much more detail down in the Canvas articles because Tom wrote it up. So we'll have more to say on this topic fairly soon, shortly, depending on how much we blabber on. So without further ado, let's head on over to What's That Sound?
Boy.
This is a journey into sound.
What's that sound?
What's that sound?
This week is a new sound week, so you'll have a chance to guess along with Tom, see who gets it right. Next week, we'll draw randomly among the correct answers for a Hackaday podcast t-shirt.
All right, here we go. First listen. Oh, yeah. Oh, I'm digging this. Whatever this is, I want it to be the soundtrack of my life. I mean, I'm sure there's somebody out there screaming into their audio playing device right now saying, how do you not know this? I imagine it's some kind of a game or something, or at least it's attempting to sound like a retro game, but I don't recognize the tune off the top of my head.
You're pretty close to right. It's an old video game. The question is, which one? If you out there know, head on over to hackaday.com/podcast. Scroll down to What's That Sound, fill in your handle and your guess, and we will see who gets it right next week. My first hack this week is a neat one from Kokensha Tech, simplifying the smart knob. If you were lurking around Hackaday 4 years ago, the haptic smart knob project from Scott Bez came out. And this was super cool. He used a coreless, brushless DC motor that I think was originally meant to be like put in a camera gimbal or something, and then put one of those nice round LCD screens over the top and made it clickable and turned it into a knob with a pressable button and a display. The gimmick with the motor as the turning element, though, is that you can provide force feedback. And so half the fun of this was all the software he wrote to give it like fake detents or spring back to center or, endless rotation, all sorts of things you can do and change the way it feels on the fly. And then coupled with the graphical feedback, it was honestly the coolest input device I've seen in quite a while. Flash forward to today, you can actually buy them as kits because he made this project open source. But still, assembling them is kind of a tricky task, getting the wires up through the center. And he used a really neat method to detect pressing the button. That is, he had some cutouts on the PCB and used regular old surface mount resistors as a strain gauge to see when you pressed hard enough that it actually bent the PCB a little bit, put a little strain on the resistors, and then he had, a 4-way Wheatstone bridge and could sense when you were pressing on it. Really, really cool. but difficult to assemble. And this is what Kokenshaw Tech is kind of taking on here in simplifying the smart knob. He's got a couple good ideas here. One is if you take the display and you put it off of the knob, yeah, it's not as sexy, but it simplifies all of the wiring and it makes some of the things that were really super hard in assembling it no longer so difficult. But the other thing it does is it means you don't have to use a gimbal motor with a hole in the middle. You can use any old brushless DC motor. And so he's got examples here of him using like a quadcopter motor or like a, just a regular old hobby airplane motor instead for the knob. And I think that's really cool. He's simplified the motor control board. He's split it into two. So there's a sensor board and a motor mount board. Yeah, he's used the standard ESP module instead of the super tiny one that Scott did. Scott's model is significantly sexier. Like it's smaller, it's tighter, it's the object you want. This one is the object you want to fool around with if you're going to be developing one of these yourself, or if you want to play around with different motors, or if you want to play around with different feels, or if you aren't worried about having the screen in the center of the device, or you want different clicky mechanisms, etc., etc. It's just really cool to see someone taking a project that was so finished, but also so finicky, and kind of unpacking it and trying to make it simpler and easier and more approachable to use. And he says this a lot throughout his video and his write-up, that he's doing this because he really likes this original smart knob himself a lot, and he bought like 6 of them, I think. But he wanted to experiment around with it. He wanted to riff on it. He wanted to hack on it. And so he's like taking a couple steps back in terms of sophistication and polish and making something that's simpler and modular and can take any old motors and you can just play around with. And I just really like that idea.
That's the beauty of it being an open source project, right? I think that especially with open source hardware, maybe there's sometimes this idea that like, well, it's only open so that I can make a 1-to-1 clone of it, right? Or
right,
or somebody can make a knockoff and sell it for cheap, right? And I mean, yeah, I mean it's possible. That's certainly possible with open source hardware, but it gives you this opportunity to do a remix kind of deal where you take the core parts of something and you spin it off and into whatever. And it could have went the other way too, right? It could have been the original project was kind of functional but chunky, and somebody else took it and made it the slim, sexy version, right?
right, yeah.
It either could have happened. In this case, it kind of went almost the opposite, right? Because like you said, the starting point was so high. It was a fantastic project, and this makes it more accessible, if not actually, better, quote unquote. But as a larger thing, I think you said a lot about this project itself, but I think what the larger concept here, which is really interesting to me, is just how much we've seen custom peripherals in general. And that's like entirely made possible by low-cost microcontrollers with native USB capabilities, right? Like nobody was making their own input devices back in the day. Or I guess you could, but you'd have to be the grayest of graybeards, right, to figure out how to make like a macro pad in the early 2000s or something, right? But now it's trivial to the point of it's a beginner's project, where you can get, an ESP and you solder a couple whatever switches, rotary encoders, lights, and then you run turnkey firmwares for doing macro pads and keyboards and stuff. And it really is it's just really cool to see all this creativity that has been enabled by like I said, the low-cost hardware and these open source projects, and it's stuff that may not have been developed by the commercial market, right? A lot of it's niche enough that like nobody would necessarily make this and sell it in the traditional sense, but the community can certainly put it together and put it out there and offer it as a kit or just as a waypoint. If you're trying to do your own thing, you can use this sort of as inspiration. So it's just really cool to see the rapid evolution of input devices that has been made possible by just all the technology that we have in the modern maker space.
Yeah, and you totally pinpointed it. There's a few things that are important about open source software, and one is that I get free software. Yay! But the other is that, if you can actually look at it, you can tweak it yourself, but you can also learn from it and adapt it to be whatever you want and take this bit and, I need something that does this. Oh, look, here's some code that does this. I'm going to borrow from that. Say you borrowed it from there, get your licenses straight, and everything's cool. Like that's huge. And that we see a lot in the open source hardware community too, of course, right? I love your point that it's the open source hardware way to be like riffing on these other designs, right? Like, because that is the point of open source. So rad.
Well, my first pick this week is a story about the Yamato 1, which might sound and actually look like a science fiction vehicle, but this is a real research project from the early 90s, and it is the first, and as far as I know, remains the only, although I know the military has started looking into this again, practical, full-scale magneto-hydrodynamic drive vessel. And that's a big word. But it's the kind of idea, and in fact, if you've ever seen The Hunt for Red October or read the book, the magneto-hydrodynamic drive was at the time, kind of this fictionalized sci-fi tech that powered the Red October submarine and the reason that the Americans wanted it. But it is actually a real technology. It's just been thus far unrealized to a useful scale. The idea behind a magneto-hydrodynamic drive, which we'll just call MHD from here on out, it's like an electromagnet that uses the minorly conductive properties of salt water as a working fluid. So essentially you have electrodes in the water, and if you pump enough power into them, the water will actually be accelerated between the electrodes. The problem is, to get this to happen at any kind of scale, to move a human scale vehicle, involves insane amounts of energy, and I think in the case of the Yamato, they were using exotic semiconductor materials for the terminals and that kind of stuff. But it works. It probably is a technology that, at least with our understanding now, is better suited for like small ocean-going drones and that kind of thing, because making it the size to push people and all the stuff that people need is really kind of on the verge of technical feasibility. They're dumping incredible amounts of energy in there and moving it, like 10 miles an hour or something. You don't get a lot. I mean, this article talks about a working efficiency of like roughly 15%. Which is not great. A standard propeller is not exactly the most perfect way to move a vehicle, but at least it's better than that. I was sure when this came through that we had written about the Yamato before, because it is really right up our alley, but we have not actually. So it was interesting to finally see some coverage for this, because it is a kind of a fascinating chapter. It's not every day where somebody tries to reinvent the way boats move and gets to the point where, it was actually out there and was doing sea trials and everything worked. It was just an idea ahead of its time, right? The technology didn't quite catch up. And like I said, I know the U.S. military has recently gotten interested in this again because, there is a lot of promise here. It's effectively a silent drive, for submarines or other stealthy stuff. It's very promising. You don't have that, if anybody's seen like a submarine movie, right, that, they listen on the headphones and they can hear the propeller and they say, oh, it's a whatever destroyer coming, because, boats make a lot of noise. And this would solve that. So there's obviously some military applications there, if not anything that's of great importance to like the commercial field. So anyway, really cool to see this finally make its Hackaday debut. Also linked into the article, and I'll put it in the show notes, is that this is, it sounds like a simple concept, and it is, to the point that you can actually do this literally in your kitchen sink with a surprisingly few components. You can actually see the effect, not that your kitchen sink is gonna blow through the wall and end up going down the street, but you can at least see, you can see the water, getting turbulent in your sink to show that the concept works.
Yeah, and really all you need is high voltage across some coils, right? Yamato used liquid helium-cooled superconducting magnetic coils, right? Like you do this in your kitchen, you're probably using copper wire.
Yeah, I do not have them.
Thick copper wire.
No liquid cooled semiconductors in my kitchen, unfortunately.
No, no. My next hack this week, when electricity doesn't take the shortest path, is a great explainer video by Electrarch 240. I think he must be a power engineer by day because he's been doing a series of videos on power electronics that have been just fantastic explainers. Now, you might think that electricity always takes the path of least resistance, right? No, it does not. And that's the premise of this video. And I don't just mean that if you have two paths, all of the current goes down the less resistance one. He's got a setup here where he demonstrates unequivocally that there are two paths, one with a higher resistance, one with a lower resistance. And when he puts a mystery circuit up in front of it, he demonstrates by looking at it with a heat gun that it's taking the longer squiggly path. The trick, of course, is the mystery circuit, which is a 1 megahertz AC power supply. And so because this is AC, instead of worrying about the resistance of the two paths, you should be worrying about the reactance of the two paths. And that includes the inductance. And if you flip the board over, he's got the return path for the current doesn't follow the straight line. Indeed, it follows the curvy, wiggly, longer line. And that is the secret. That path, because the positive and negative side of the current path are basically right on top of each other, has a lot lower inductance than the other line, which is a straight line, which has less resistance. But because the return path on the other side of the board is so far away from it, it's got a lot more mutual inductance between the current going one way and the current going the other. So when you crank the frequency up, the extra inductance in that shorter path gets higher and the electrons want to flow down the longer curvy path. And this is a great demo of this effect. This is not just academic, and this is why people who do high frequency designs always tell you to not worry about your single traces, but to worry about the return path as well, to worry about how the current gets to where it's getting to on the other side of the board. And this is why a lot of high frequency stuff is designed with a solid ground plane on the back side of the board whenever you can, because then the return current can follow the forward current, on the top side of the board. It can just like follow it on the bottom side of the board. It can run through whatever bit of that ground plane copper it wants. And this matters for things like high frequency switcher circuits, especially when you have a lot of current flowing through. And that gives us, like switching power supplies, which I think is where he's approaching this. But for general designs, if you have anything that's pushing signals around at high frequencies, you can worry about like EMI and noise emission and stuff. So it's always worth thinking about, not just where am I laying out this trace? Am I minimizing this trace length? What matters is minimizing that trace length and then the return current that would have to go back the other way. Maybe it's on the other side of the board. Maybe, you put your ground planes right around the trace you're running. Either way, as tight as you can make this current loop, the less it will emit. And this is just such a great demo of that. I love that he puts enough juice through it that he can tell where the current's going, with one of those IR thermal cameras, because it's getting so damn hot. That's a cool demo.
It is an excellent presentation, maybe largely because of that. I mean, the whole video is really well done and he explains everything, but I mean, he certainly knew to lead with the cool visual, right? I think it's like Skippy. 10 seconds in or something, he's got that thermal camera, and it's as plain as day. You can see the one path getting heated up, as you would expect, right? Like, okay, path of least resistance. It's certainly the path I take anyway. So yeah, it was really cool to actually see that, and like you said, there are all kinds of concepts out there that we're aware of, and best practices, but actually seeing it happen right in a very human scale, obvious way makes it almost more real. At least for folks like us, which are kind of flailing around with this sort of thing. I mean, if you're a professional, I'm sure you're doing PCB design, you're much more aware of this kind of stuff than we might be, as the self-taught hackers or whatever. So showing us that is really cool. I also like just in general the theatrical presentation of this video. I thought it was really cool where he blurs out the circuit that's powering the squiggly side just in case you knew what was up and you would be like, oh, of course that's it's a 1 megahertz current source. That's why. So he blurs it out to kind of keep that secret until longer into the video. So I'm often critical of videos as a medium for the information exchange, but I got to give this one credit. It really does do an excellent job, and the whole thing is just fascinating to watch start to finish.
I mean, you're right. This is like one of those old design chestnuts. It's like, watch out for current loops and make your return path as short as you can. This is like one of those things that you learn. But I think looking at it in high power context and, really thinking about how it matters for these kind of circuits, I don't know. I found that this was nonetheless eye-opening in a way. Like it really is just the extra inductance that's making your rising edges rounded over and making the EMI and all of that stuff. And I just thought it was a great explanation. But like you said, it's actually a hilarious presentation and just a great video. It's actually a fun watch in one of the ground rules of power electronics design.
I think it's probably like, if you're gonna do a video, like, do a video. I
Hell
gotta,
yeah.
give him credit for that. Like,
It's got to be a stand-up routine.
Yeah, right. I mean, if you're gonna, grab the medium by the horns, right, and make it happen. Don't say, and here's the thing. So do it. If you're gonna do it, and they did it. So
Damn straight.
My hat's off to Electric Arc 240. So my next one is from Electron Update. This is looking at a real fake Raspberry Pi RP2040 board. I think anyone who's even made a cursory look on the internet for Pi Picos and RP2040 stuff knows how many variants there are. Like, everybody has their own kind of sort of Pi Pico, right? WaveShare's got it. Like, everybody, and they all bring something a little unique to the table. A lot of them say, okay, here, we added the USB-C, which of course I think many of us wonder why the official one doesn't have. And, this one adds, there was ones that added Wi-Fi before the official one did it and that sort of thing. And that's largely because the actual RP2040 microcontroller, anybody can buy. You can go buy real right now for, what are they, $1 each or something, or at least when they came out. And that has, given birth to this whole ecosystem of roughly Pi Pico boards. And it's, everybody's happy. Even in that idyllic situation, there are still some people doing shady things. And this is a look at one of those shady things where instead of, coming up with their own variant and calling it the whatever, they basically just copied the Pi Pico 1-to-1. Beyond the absence of the actual Raspberry Pi logo on the silk screen, it is exactly the same board, at least to the human eye. And that's where Electron Update did effectively a teardown. And you might wonder, how do you do a teardown on a Pi Pico? And you literally, pull every chip apart and look at it at the die level and see what's real, what's not. The short version here is that, as far as he can tell, the RP2040 itself appears to be legitimate. And he mentions there's an article and then a companion video for this, and he mentions that that might seem like a weird thing to have to say, because who would clone this chip? But he's like, but you'd be surprised the lengths that some of these Chinese manufacturers will go just to save pennies. But in this case, it does appear that they are using the real article, or at least an exceptional clone of it, right? Because even tearing it apart and decapping it, he couldn't find any obvious signs that it's not the real deal. Everything else on the board...
Except. It's not a fake RP2040, but it's an RP2040 from a previous run. He looks at the die, and it's the B0 revision. It's the first revision of the chip, which has some bugs in it that got fixed since then.
Yeah, and they're debating that in the comments. There's like two schools of thought there, because they said unless and until he pulls apart a second version of the RP2040, we don't really know that all the markers inside were changed. you know?
Oh, what if the newer ones don't have...
Right, there needs to be a comparison to the updated stepping of the RP 2040 because it's possible like the stuff they changed was on a different layer and they wouldn't necessarily have changed every layer.
Right.
So, yes, there is a weird discrepancy there, but there hasn't yet been somebody pulled apart a new one to say, is that what it's supposed to look like?
Oh, and look, compare it to this one. I see
Right.
what you mean. Okay, fair enough.
But you're right. Yeah, you're right. There was a weird thing in there where the inside it says it's a version 1, on the outside it's a version 2. To simplify it basically.
Yeah,
But
exactly.
is that wrong? That's not clear yet until somebody goes and actually and I think that he probably will because there's been enough people talking about it in the comments to say like, is this legit or is it just an artifact from the version 1 chip that is still in the version 2? You know what I mean?
I bet you dollars to donuts they changed their revision label on the next version of the chip. I bet you $1 million this is not $1 million. I bet you $5. See how quickly he steps back. They changed it to say, revision 2 stepping, revision 3 stepping on the more modern ones, and that this is an old stock chip.
Well, it could be that. Yeah, it could be an old chip with they just lasered on the newer release info on the and we've
front,
seen that, right?
Which
We've
is
seen,
fraudulent.
Yeah,
Which is fraudulent.
but at least would still be a real chip.
I mean, it's a real RP 2040. It's just not the
perhaps
one
an
it says
old-
it is.
Old version.
Yeah,
Yeah,
and
all
that's
right, so
that's my
there
guess is that it's a real, it's a real functional chip. It's just the
Yeah.
one. What it had some ADC problem with it. There was some issue with one of the ADCs on channels not reinitializing
Right.
There were some weirdnesses in the first run.
And it caused some problems, and we covered that. We could put that in the show notes too. We covered that there was some weird stuff going on, but it was the kind of thing that most people wouldn't notice.
Yeah, you could totally, and you can work
yeah,
around it if you need
right.
to, and.
I mean, I
But-
think that the Bus Pirate 5 kind of was one of the few things that actually they might have
They got
actually
bit by that.
I think they discovered it actually.
Yeah, that's
Because
right.
they were pushing the chip in ways that most people weren't, and they said, "Hey, this is a weird thing." And then I think initially Raspberry Pi was like, "Don't worry about it. Doc, it hurts when I move my arm like this." And they're like, "Well, don't move your arm like that."
Exactly.
But they did eventually fix it. All right.
But
well, so
they fixed it.
yeah. So all right, fair enough. Potentially, it is an older version of the 2040 marked as a new one, but it is, as far as anyone can tell, a real 2040. The other
Right.
parts on the board are definitely not legit, and that's kind of where it maybe is arguably more interesting because they are one-to-one drop-ins for the flash chip and the voltage regulator, but they just aren't. They aren't the ones that aren't supposed to be there, right? They've been swapped out for cheaper, probably, he assumes Chinese manufactured native versions of the chip, right? Like they're not going to use a TI voltage regulator or something, right? They're going to make their own, not necessarily clone of that voltage regulator, but a one-to-one compatible version of it. So and he pulls everything that can be pulled apart is pulled apart and shown at the die level. The short version is it works. It's
right.
It's half the price of a Pi Pico, which is already remarkably cheap anyway. These were going for $250. It's half the price and appears to work just like the real deal. So for the garage hacker, it's not a big deal, but it is interesting to see that even for a $4 microcontroller development board, there's still companies out there that are trying to make a buck and shaving off pennies to create a cheaper clone.
This whole thing starts off with the question, how do they do it? And the answer is they do it by cutting every corner they can, right? Like they use cheaper flash. They use off-brand components for everything else. They maybe use an old stepping of they maybe use an old version of the microcontroller, maybe mislabeled, and that's a little bit unethical, but whatever. You could do this non-sketchily. You could say, look, we're running off the old, we got a truckload of the old chips and we got them cheap. We're going to make boards out of them. And it probably won't matter.
Right.
I'm not a design for manufacturing engineer. Using lower quality components probably ends up with a higher failure rate in some weird margins and stuff like that. And that's probably why Raspberry doesn't want to deal with it. They'd rather just have them all work straight out the gate. And I think these are probably, works 90% of the time is a bargain if it's half the price, right? So, I can't blame them either. So kind of cool, but I have to say, no surprise. How do you make something cheaper? You use a lot of cheaper parts.
This is true.
Yeah, it's not like we don't buy surplus electronics.
Yeah, right.
We're cheap bastards. Well, my last hack this week is an open source electromagnetic resonance tablet. There's a write-up of a fantastic project by Yuki Dama to recreate, those kind of pen tablet input things that I think of as a Wacom tablet, right? Like they're kind of the biggest manufacturer of these. And they are really cool in the way they operate, and I love that he has taken it on to kind of recreate this whole ecosystem. The way they work is they've got on the tablet itself, they have a bunch of coils in kind of oriented in the X direction and the Y direction. And the pen, the stylus, has a coil in it and a capacitor that it uses to resonate at a given frequency. And so what the coils on the sensor tablet go bing, 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 bing. And then the little coil inductor in the pen rings for a little while after getting energized by these. And then the tablet coils switch from transmit mode to receive mode and listen to it. You multiplex these coils, so you scan across X, you scan across Y, and then you can look at the different received signal strengths and figure out exactly where the pen is. And that's how those things work. They're really cool. One of my favorite things about the way these work is the pen also has buttons on it. And these pens don't have any batteries in them. So how does it know what the buttons are? The buttons just switch in different capacitors, and so they change the resonant frequency of the pen. So when the coils on the tablet hit it, it vibrates with a different frequency. And when the tablet switches back to receive mode, it can tell that the pen is vibrating back at a different frequency and thus has one of the buttons pushed down. That's also how the analog pressure sensor on the stylus nib of some of these things work. Again, it pushes a little inductor up into the coil and changes its frequency depending on how far you've pressed the pen nib down. And then the board reads this back. So what I really love about this is it's a complete recreation of this kind of the tablet side of things, and he demonstrates how it all works. He documents how, 8 or 10 or 15 different professional tablets work in this project Patchouli here. Again, most of them are Wacom tablets, but some of them are other ripoffs. And they have he finds that they have a bunch of really cool tricks to kind of optimize things. My actual favorite one is that since you're just detecting one pen and it can only jump around so quick because it's being controlled by a human arm, you don't actually have to scan all of the coils. You only have to scan the coils in an area around the last place you saw the pen. And so by doing this, you can drastically reduce the number of coils you scan, which increases your refresh rate. And he says you can get refresh rates up to like 1,000 hertz, which is pretty crazy. When it doesn't sense the pen and it just wants to know where it is at the first place, instead of energizing one coil, you can energize pairs of coils that are sufficiently far enough from each other and step these across. So you can do like 2 coils or 3 coils at a time. Instead of one scanning across, you can scan 2 or 3 across, which again doubles your rate. And so there's all these like really cool details about how these tablets are optimized, and then he builds it into his own. The like pièce de résistance here is he rebuilds one of these grid networks on a flexible PCB, puts it behind an old laptop's LCD screen, and converts the laptop into a pen tablet laptop using his own circuitry. And that is just so rad.
And I think that's a great takeaway, right? Because you could look at this project, and I think you could probably do this with a lot of open source stuff, right? The naysayer would look at this and be like, well, what do we need this for when we have Wacom pads, right? And they're good, and they're like a solved problem, and I'm pretty sure they're already, compatible with everything that's out there, and they're not crazy money. What's the point of doing like an open source hardware version? Isn't that just work for the sake of work? And maybe, right? I mean, maybe some of these projects are, just replicating something that exists because the person was bored one day and wanted to know more about how something works. But once you have that baseline, then you can start to see these expansions, like you were talking about, implementing it into the laptop, right? Like that's a forward step that couldn't be made until you have a base to work from. Even if in the short term it seems like you might be just kind of banging your head against the wall, making an open source version of something that's already out there and it's kind of like the accepted standard. You never know where that spin-off will take you, right? And you can't start the journey unless you take those first steps.
Yeah, and totally. And going back to that open source hardware stuff, Yukidama here cites Scanlime, who did some reverse engineering work on the Wacom tablets a long time ago, back in 2016. I know we covered that on Hackaday. 2016, glitching USB firmware for fun was a story about breaking the USB side of the firmware on one of these Wacom tablets, but is in part of like an 8-part video series in which Scanlime goes through how these tablets work and recreates it, and logic analyzer probing and stuff like that on it. Really, really super kind of early documentation on these that then Yukidama's one here just totally builds off of, expands on. Yeah, I just think it's such a cool, like how these styluses with no battery in them actually work is so kind of almost magical, right? But then in the end, it's so stupid simple. It's like, it's not even RFID, it's just a coil and a capacitor inside the pen, and then some different things to tune it depending on whether you're pressing a button. I just love the simplicity of it, and knowing how to build these circuits means you can put this kind of device into a project of yours, and that's the hacker spirit.
All right, well, my last pick comes our way from Dynamite. Ooh, I like I like that name. This is a ESP32P4 powers retro handheld after a transplant. Say that 3 times fast. This is a really cool project. It is something that is kind of close to my own heart because I've certainly thought about doing this, as I imagine many people who have, right? Because you can go on Amazon or wherever, your favorite online retailer, and there's all these super cheap, like $20 retro handhelds that are, running bootleg ROMs and kind of suck. But, for $20, they have hundreds of retro games. And I think both of my daughters have them. They're cheap little things and they're okay. But if you take one apart, and in fact, I did. I think I'll have to find that. I did a teardown for one of these for Hackaday, and I'll have to link that in. If you tear it down, it is almost invariably just a giant epoxy blob on the board, and there might be, an SPI flash chip where the ROMs live. So maybe you could swap out the ROMs, but it's, it's one of the usually like one of those NES on a chip kind of deals, and there's not much room for improvement. Unless you measure the PCB and figure out where all the mounting holes and connectors go and just make your own PCB. And while you're at it, why don't we put the newest and most powerful ESP32 on there, which runs at 400 megahertz RISC-V and can emulate up to like the Genesis level and that kind of stuff. And that's what we have here. We have a replacement drop-in board for one of these cheapo handhelds that vastly increases its power and at the same time allows it to run the RetroGo project, which is a very cool project that I'm surprised. I actually searched before we did the podcast. We've only mentioned it once before. It is a multi-console emulation front end for the ESP32 that lets you do like Genesis, Mega Drive, NES, Game Boy, all the hits, and like the old Ataris and stuff. With like a really cool like graphical UI to pick them. It's actually it's really, really cool project. It's, I guess, the like Retro Arch, I think, is kind of the the full fat alternative, right, that people are doing like on the Pi and stuff, because it's now so cheap and easy comparatively, right, to have your own PCBs done. Making a replacement motherboard for one of these things is not trivial, but not anywhere near as difficult as it would have been even a few years ago. But making a nice injection molded enclosure with decent buttons and a properly fitted screen and a battery compartment and that part is still relatively tricky, right? So by taking one of these cheap off-the-shelf things where all that hard work has been done, they already have an enclosure and you already have all the skeleton is there, right, for lack of a better word, and you just change the brain, you end up with a really compelling final product that would be much tougher to achieve if you had to start from scratch. You know, of course you could 3D print the case, and you could find somewhere to source the buttons, and you could figure out a screen that will fit it, but, you know, that's a lot of extra work. So using one of these little cheapo machines as a jumping off point, I think was a really, really clever idea, and saves an incredible amount of time and effort and lets you focus on, frankly, the interesting part, right? Like making the board and getting that working with the software and stuff. So really, really cool way to take one of these okay devices and make it something that will be the envy of the makerspace.
My first quick hacks, hacking the Krupp's Cook For Me smart cooking pot for Doom. Here we are in the timeline where a smart cooking pot adapted to run Doom is only a feature in quick hacks. But honestly, Aaron Christophel's work here was pretty simple. The board had a nice beefy microcontroller with more than enough memory, and it was easy enough to upload code to it. Still, it's really sweet the way he used the whole touchscreen to both do controls left, right, up, down, and shoot while also displaying the game. Sweet, sweet hack. Pen test partners, great trains, not so great AI chatbot security. This is the story of a chatbot on the Eurostar website that got busted. It basically records the whole transaction history with you, sanitizing each input as it goes along, but not looking backwards in the chat history to make sure that all of the previous things you said were not trying to mislead the AI chatbot. And so there's a bunch of fun prompt injections here. You should definitely check it out. DIY guy Chris, an SD card of your own for microcontroller projects. We've all taken an SD card and soldered it into a microcontroller project, but that's silly if you are never going to pull it back out. Why not just buy the chip that's inside this SD card and deal with it directly? It turns out it's super easy to do, and this video shows you how. I mean, basically it's just wire out the lines and give the thing power. There's nothing to it, but how cool would it be to have your own USB capable SD card embedded in your own projects, on the PCB in your own projects built in. Really sweet. And last up, Jerry Ellsworth has a funny tweet / blue sky post making a CRT spin right round, round, round. She takes the yoke on an old CRT screen, puts it on a slip ring, turns it with a stepper motor that's controlled with another stepper motor, because motors are generators, and spins it. And what this does is it spins the image without spinning the TV. I have no idea what kind of craziness she has in mind for this, but it's such a cool demo. I want you to see it and speculate wildly about what she's actually up to.
Well, my first quick hack is smart home. Make it smart quarters with this LCARS dashboard. And you must be a certain type of nerd, I suppose, to appreciate this. But this is an effort by Steve Gibbs 5. No word on what happened to the first 4 versions. That he wanted to recreate the LCARS interface as made famous by Star Trek The Next Generation for his home automation system. And what I liked about this one is when you really dig into it, it is about using a handful of Android tools, Total Launcher, Tasker, the list goes on, and combine them to make a custom graphical user interface. In this case, it looks like LCARS, but it could look like anything you want. It could be any other, sci-fi show's interface you wanted to clone, or just something of your own design. Steve doesn't really get bogged down into what it's running on, because that's kind of inconsequential. He shows it running on phones and tablets and yada, yada, yada. But it's really, if the thing can run Android and you can install these tools, this is how you make your own custom UI and how you hook that up to the real world. So I think it's a really cool reference for that, even if you are not a Star Trek fan. God help your soul. Next up is Windows, Linux, browser, same executable. This is a really cool software hack from Camilla. And the idea here is that it is one file that can run on Windows, Linux, or open in a web browser. In this case, it is a simple Snake game, but it could be whatever. Now, the interesting thing here is this is not some kind of sorcery that allows the same actual executable to run in all three conditions. It is three distinct files that have been smushed together and are wearing an overcoat that makes them look like a single file. There's some trickery here. The short version is that there's enough leeway in like the Windows executable header that you can basically tell it to, well, just skip over that other crap, the other crap being the Linux executable, and it'll still work. And vice versa, right? You can tell when it's running on Linux, you can say, don't worry about that weird garbage over here, just focus on this, and the garbage being the Windows version. So it's really, the trick here is really in that kind of header and the abuse of the header format to ignore stuff that isn't important and redirect execution to what is. I would not advise you distribute your software like this in the real world, but it makes for a pretty cool little tech demo. More just a, fun operating system tricks to show your friends.
Hacker resume.
And then finally, I have EnderSpark, convert your broken Creality FDM printer into an EDM machine. And no, we're not talking EDM, electronic dance music, but we're talking about electrical discharge machining. The 30-second elevator pitch is basically you're using a spark to erode a conductive workpiece, and if you do that enough and accurately position your electrodes, you can cut a piece of metal, or you can make holes in it, or you can etch it, and you can do all this kind of stuff without, the traditional chips being generated from like a CNC, or without the insane expense of a laser capable of cutting through this kind of metal. It makes metalworking stuff a lot cheaper and more accessible for the home gamer. Downside being you need a big vat of water at decently high voltage, so there be their own dangers. The larger thing though I liked about this, because it is not the first EDM machine we've seen, but I did like that it is yet another example of just folks doing stuff with cheap last gen 3D printers. And this is something that we've kind of talked about internally, with the new wave of 3D printers and, everybody's buying bamboos and just how the state of the art has kind of moved forward. There's a whole bunch of Ender 3s and similar machines collecting dust. So I think we're going to see more and more of projects like this where you just kind of bolt on a new tool to what's already essentially a perfected motion platform, and you turn your old printer into something new rather than more e-waste, which is always cool to see.
That brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I got Brian Cockfield's A Linux Power User Puts SteamOS to Work. And this is the story of him going out on the road with a Steam Deck instead of a normal laptop. I actually do this too, which is part of why I picked it. I think it's really fun. I know a bunch of people in our comment section have said they also use their Steam decks as real computers, because under the hood, that's what they really are. In fact, it's an Arch Linux distribution, but it's an Arch Linux distribution that's kind of got this Steam overlayer that makes it super easy to run Windows software, but also is almost like an immutable distribution in the sense that you are supposed to mostly install software as flat packs, and every time it upgrades the operating system, it takes all of the operating system stuff and just completely wipes it out and reinstalls it. And this means that if you install software in like bin or user bin or any of the kind of normal places to install software on a Linux system, it gets wiped out every time. And so part of the story here is how Brian deals with this and how he fits it into his regular workflow. And I think some of the interesting stuff here is most of the productivity tools you need probably are easily picked up with a flat pack, and you actually don't have to do much. Like, you're playing video games, you hit power, you hit switch to desktop mode, and boom, you've got a KDE desktop and you're running Linux and, open up a browser, do whatever the heck you want. And that's actually a really super nice and super streamlined experience. He uses SyncThing to transfer files among his various computer systems. So, if he's working on something here, he can do it there. But he also finds as a side effect, though, it lets him transfer save states in video games that he's playing between the deck and his main computer. So he can also install Steam on his main computer, keep playing video games there, and then update them into his SyncThing cloud and then take them with him on the road on the form of the deck. But the focus here was getting work done. What's funny is that I've been doing this too. When I went out to SuperCon, I didn't bring my laptop. I only brought my Steam Deck, and I did a whole ton of work on it. I took kind of the next step in the Linux power user direction, and I took it out of read-only mode. And it's so easy to do. There's actually, Steam's provided a script to do it. It's not hard. It's sudo steamos read-only disable, right? And then, of course, you've got a straight up Linux system. Then you can write whatever to it. You update Pacman, which is Arch's package manager. You update the repository, you point it to the right one, and you can install anything like it's a normal Linux distro. It's absolutely fantastic. The one catch, of course, is that the next time Steam updates, all the stuff you've installed gets wiped out. My horrible solution is to just take a note of which packages I've installed and put them in a text file. And then when they get wiped out, I just reinstall all these, and it does it. And honestly, it takes about 10 minutes and I'm back to a working system again. And as long as I take good notes, it's like any other build script. It comes back up the way it should. There are better ways to do this. I know the way NixOS deals with being an immutable distribution that you can then add things to. You put stuff you want to keep in your home directory and then you make symlinks to it. That's pretty clever. But, it's an extra level of sophistication. I really literally just have a text file with a list of the packages. I was flying out to SuperCon, so I had to be able to recompile the MicroPython version we were using on the ESP32s on the fly because we were adding some extra libraries that we wanted baked in and stuff, which meant I had to have the whole Extensa compile toolchain. And you can imagine that there isn't a flat pack for this. Not everyone is compiling bare metal ESP32 stuff. But it's a dead simple to, tell Pacman to go get you that tool chain. And so you just do it. And lo and behold, a week before I left for that trip, the system updated, wiped out everything I'd been working on. And I'm in the airport in Munich, about to hop on the plane. I notice this. I run the script connected to free Wi-Fi in the airport, and it completely updates everything. I hop on the plane, and it was a piece of cake. The beauty of a Steam Deck as a computer is that it is so battery efficient. If you're just using it in laptop mode and not hammering the GPU, it gets 10 hours. I was working the whole flight over. You need a keyboard. You need a Bluetooth keyboard. You need probably a Bluetooth mouse. If you have a little dock thing, you can actually plug your plug mouse in there. That's what I do, but too damn many cables. I'm going to buy a Bluetooth mouse someday. Totally doable. I think taking the next step and installing something like NixOS or Bazite is super popular. There's also one that I've been meaning to try out called Cache OS. And I was actually talking with Anfractuosity over on the Hackaday Discord about this. It's got scheduler that is extra responsive, used on constrained devices, like the Steam computer, I guess, is a little bit constrained. There's a whole bunch of options if you're willing to blow away the original Steam install. You could still install the Steam layer over the top and play your video games and nobody will know. But I guess you lose Valve's update path if you do that. But we're all big kids. We can run our own computers.
I'm not surprised you picked this one because, your personal experience with it. But if you didn't go with it, I was definitely going to go with it because we have seen, just in the sample size of SuperCon nerds, more and more attendees are bringing Steam Decks and working on them during the, in the alleyway. So I've been actually interested in their non-gaming usage too, and it is interesting to note that a decent amount of work on the badge this year was done via Steam Deck. And in fact, I think when we were flashing them, right, 2 of the flashing stations were Steam Decks. Yeah.
That's right. There was mine, and then Victor was like, "Oh yeah, I got a Steam Deck over there. Let me haul this up and start flashing them."
Yeah, so there's like a 2 in 5 chance that your SuperCon badge was flashed via Steam Deck.
That's right. I forgot.
So they were putting in work for sure, and it's so that part's really interesting. That there is legitimate work to be done. I think when I saw the first, it must have been two SuperCons back, like the first guy who brought one, I was like, look at this dude, what's he doing? What's he doing with this thing?
What a goober.
Guys, he's sitting here and he has a little keyboard, and I might have chuckled to myself and like, man, we got some types coming in here. But steadily every year there's more and more of them, and now they're damn near part of the official production of the event. So yeah, I mean it's not a one-off anymore. More people are doing this, and like you said, there's excellent reasons. The efficiency, I think some firmware work in those last moments, we were kind of doing head-to-head between whose battery would go first. Yours on the Steam Deck and mine on a Lenovo laptop, and seeing who would have to plug in first. And I think I did. I will take that shame. I believe I had to plug in first. Yeah, so that part's really cool. And of course, work in the front, party in the back, right? So when you're done doing badge hacking, you can play your game. So I mean, there's obviously an appeal there, and I think that it's really cool that Valve has made it open enough that kind of thing is possible, right? Like, they didn't have to do that, but I think someone over there realized, hey, it can only help things, right, if you could turn the switch and use these as proper Linux boxes, and there's going to be a certain, the Venn diagram of people buying this for gaming versus people who might want to compile some software is, there's a little bit of overlap there, right? And they made clearly the right choice because people are digging it and buying it. For that, right? Like, I don't know that necessarily everybody who had one would have bought it if they couldn't use it for non-gaming purposes. So it's an interesting article in that respect, right? And that's actually what brought me in the first place. But then I was kind of surprised, and in reading it, that the article itself is at least like 50-50 about the concept of these immutable distros too. So there's, even if you're not into the Steam Deck necessarily, there is, some practical talk about what it's like to work with one of these immutable setups and the hoops. And I gotta say, it sounds terrible to me. the idea of the immutable distro and doing flat packs for everything, like, that's not the way I want to work. But I absolutely understand why they would do that for the Steam Deck, or honestly, even why you'd do that for a lot of desktop users. If you're deploying a bunch of these machines and, your users just need a browser and an office suite and whatever, hell yeah. To tie up as many loose ends as you can, right? And just make it a simple thing. So I get it. It's not would not be my first choice. Like you, I would be running whatever command is required to turn that off immediately. But it's obviously there's technologies and stuff out there that are not fit for all of us, but they have their place. So this is one of those things where I can clearly see the advantage, but keep it away from me personally. It's amazing. I mean, I would never have believed, honestly, if you told me 10 years ago that we'd see something like this from a company like Valve. This isn't even like some weirdo, in somebody's garage and they make 10 of them a year. Because there's been Linux handhelds like that, absolutely, in the past, right? But this is big time. I mean, and it's just really awesome to see. I mean, of course, Linux is everywhere anyway, but this is a very, like, in-your-face version of that, so love it.
It's even more Linux on the desktop than Linux on the desktop. This is Linux on your gaming console.
Yeah.
Like, how much more end-usery could it be, right?
If this is not the year of Linux, when will it be? We have it on everything. It's on the phones, it's on the gaming consoles, it's everywhere. You just might not know it.
And the funny thing is, the Windows emulation stuff, Proton, which is a spin-off of Wine, is so good that it runs a lot of games faster than they run on a similar computer natively in Windows. And that's just, like, mind-blowing that this emulation layer over a Linux kernel runs the same damn software, but faster. But it does.
if you're talking about the Steam Deck, you do have to give Valve credit for doing that, right? Because all that work to make, not every game, but most of the big name games run properly on the Steam Deck, all of that work went right back into the community and is available for you on your desktop. Even if you've never seen a Steam Deck, you can use that because it was all, all done in the open. And again, they didn't have to do that. They could have squirreled it away and made it their own proprietary thing. And there are companies that will remain unnamed that would have done it that way, and I really, really appreciate. I'm not a gamer, well, at least on PC side anyway. I've never been really into that myself, but I do got to give Valve props for doing this and having the foresight to say, not only let's get away from Windows as a platform for gaming, because that brings a lot of baggage with it, but let's make sure that all the work we do goes back out into the community, and that it's a transactional kind of thing so that everybody benefits. I mean, this is awesome. It's like I said, it's the kind of stuff that would have been a pipe dream not that long ago, and now seeing it happen in such a big way is really, really great. I do gotta say, one of the highlights of SuperCon for me is seeing what evolution of the traditional computing form factor you've come up with this year. Because I think last year you were real big on the external like USB-C displays.
Yeah,
and I think you had that with the Pi, right? So you were
still am.
I could have the Pi in the plane with the screens, and now it's the Steam Deck. But I think you also had the screens too. So
Yep. Yeah, that's right. I forgot I did this with the Pi on the plane last time.
Yeah, there's always like this evolution of like, I could have brought the laptop, and you still bring the laptop anyway.
I had brought the laptop last year. That's right. I forgot I did it with a Pi 4 last time. Pi 4 and external monitor. That was pretty good too, actually. Oh no, I had one of the Pi 400s, didn't I? I brought a Pi 400 with me. The cool thing about all these is that you could plug a power bank into them if you need more than 10 hours of battery life too. Like, I don't know, I probably could have gone 20 hours with the Steam Deck and a power bank.
Well, I won't say that I personally picked my own work, but the newsy nature of this did, I think, require us to talk about the article I wrote, which is ISS medical emergency and orbital ambulance ride. This is, as we said at the beginning, the ISS had its first ever and, hopefully only medical evacuation. We don't know exactly what happened, and there's a good chance we'll never have all the facts because it is a private medical thing, and if it was you or me, we wouldn't want necessarily everybody in the world to know what happened. We can make some assumptions based on what was out in the public and the timeline of things, and we could sort of surmise that whatever happened was serious enough to come home, but not serious enough that they stayed up for a week after it occurred, right? So this wasn't like a massive heart attack or something like that, but it was something troubling, right? It was troubling enough that they didn't want to wait until interestingly, there actually wasn't, when I was writing this article, I went back to say, like, well, when were they supposed to come home? How far was the schedule moved up? Kind of unfortunate in hindsight. They were actually, with this Crew 11 mission, they were actually talking about not having a set end date and sort of just kind of like playing it by ear, because the Dragon has shown that it can stay on orbit for longer than was initially contracted for, because these, you can't just, stuff happens, right? You can't just have these capsules waiting indefinitely. But they found that, the Dragon was like rated for 6 months, but it can do longer. And at that point, you're really just talking about human endurance. So they were saying, okay, maybe on this mission, we'll see 7 months or 8 months, and we'll just kind of see what happens, right? Like, there's no shortage of stuff to do on the space station. And for the most part, once an astronaut gets in space, they're pretty happy to stay up there. So there actually wasn't a predetermined end date that I could find for this mission, but at the very least, it was supposed to go until the next crew came up in February. Again, whatever happened was bad enough that they said, well, we can't wait until February, but, next week's okay. So, make of that what you will. And the logistics of it is that if one person has to go home, everybody goes home. And that's the real bummer, right? Because it's extremely expensive and difficult to put a person into space. So everybody who is up there has a lot of stuff to do. It's only logical that you'd make the most out of their time, right? I mean, obviously, I think we've written about this before. In the early days of the space race and stuff, the astronauts were actually worked so hard they just kind of freaked out. Like if they were awake, they were doing something. Like you're gonna be running a test, you're gonna be turning a wrench, you're gonna be like, we paid a lot of money for this, get to work. It was very, very stressful on them. So now they do have, rest periods and that kind of stuff, obviously. But outside of that, they're working. I mean, there's always something to be done. That stuff is planned and scheduled to a degree that mere mortals like us cannot even fathom. Imagine every moment of your life being on a checklist and scheduled a year in advance, right? So when one of those people is out of commission, that sucks. When 4 of them have to leave before all that stuff is done, now you have a fairly serious problem. Just logistically, all the stuff they were supposed to do now has to be done by somebody else. And now, admittedly, not everything on the space station is of critical life or death importance. There are literally like grade school science projects that are done and recorded as like outreach and stuff like that. So, okay, fine. You drop that stuff off the schedule and whatever. There are things that can get pushed around, but there's other stuff that obviously is very important. The key thing that is going to be, tricky going forward is that this crew was supposed to do at least one and possibly a second, actually, EVA, where they were to go out and do prep work for the upgraded solar panels, which the next crew was supposed to install. Obviously, that didn't happen. So now you have a situation where the next crew is coming in February, and they've been training for a year or whatever for this installation of solar panels, which, the groundwork has not been laid for now. And that is not great. So there's a question, and NASA did address this a little bit in like the press conference. They're going to have to do the work that wasn't done already, which is going to make obviously the spacewalks longer, and you can only be out there for so long, and it's a domino effect ultimately. They'll figure it out. They've been doing this for almost the 30 years that the space station has been up there, so they will work it out. But it is disruptive, and it's going to have implications that are probably for the rest of the year. The schedule is going to be kind of jumbled up, but that's the reality. And from the get-go, and this is back in the 90s when they started talking about the station, before the Russians even got involved and it was going to be Space Station Freedom, they said, okay, well, if you're going to make a space station and you're going to have it fully crewed 24 hours a day, 365, well, obviously you need some kind of a escape pod thing, right? It seemed like that's just, you got to have a way to escape in an emergency. And there were different concepts and there are different prototypes even built. But ultimately, as we now know, it never happened. And it just became one of them things where like, well, if something bad happens, they'll just ride their own capsule back. It never came up because there was never a medical issue until just now, right? So this is the first time they're dealing with the reality of, man, it would have been nice to send just the one injured person back, and now we have to deal with the fact that everybody went back and all this work isn't done, and now the schedule's backed up for who the hell knows how long. It's NASA, right? Like everything is studied and restudied and reported, and I think there's probably going to be some internal talk now that says, hey, did we make the right call? Given everything that's now going to have to get changed and redone and redundant work and money lost because especially in an era with shrinking budgets, was it the right decision to not spend that upfront money and have a little escape pod thing that they could have used in this case? Or do you just kind of, is it a numbers game where you say, hey, the likelihood that we'd ever need it is so low that we'll deal with it if it ever comes up? So personally, I'm interested to see what is learned from this, because there's obviously talk of commercial space stations in a post-ISS era and the moon and someday Mars and whatever. There's always that possibility that somebody's going to get hurt or have a medical emergency or whatever. What lessons will be learned from this that we can take forward?
That does it for this week's Hackaday podcast. Thanks very much for listening. Show notes are at hackaday.com/podcast. And if you want us to write something up, tips at hackaday.com. And until next week,
keep on hacking.
That was a rolling something and then somebody playing Mario.
Yeah, very good. Very good. That was the impromptu What's That Sound?
It's super creepy. It starts off with the
Okay. Yeah, even cool. I think that's a good one there. I think that one's in the can. The idea for a
Oh man, I went super nerdy this week.
It's cool. I think if they're listening to the podcast, they're okay with it. Man, yeah, boom. I mean, we're on fire, this one.